All right, so I think I'm recording. We're taking a look at problems for the semester review for college algebra. And here they're just giving me two functions and they're asking me to perform function operations of addition, subtraction, and so forth. So it's pretty straightforward. This is the notation for f of x plus g of x. F of x is 3 over x minus 4. G of x is 2x over x minus 2. But in order to add these fractions, I do need a common denominator. So I need to multiply this by x minus 2 over x minus 2. I need to multiply this by x minus 4 over x minus 4. So I'm multiplying each one of these terms by the number 1, so it's not changing the value. But look at my denominator now. I have x minus 4 times x minus 2. And you can write x minus 4 times x minus 2 in any order. So this product is the same as this product. This denominator is the same as that denominator. So now let's take this 3 and distribute it through this binomial. We've got 3 times x minus 3 times 2. Let's take 2x and distribute it through here. So we have 2x squared minus 2x times 4, 8x. Let's simplify this numerator. I'm not even going to bother multiplying the denominator together because sometimes it's nice to have it in factored form. You know, for instance, in finding the domain, I can see the domain is all real numbers excluding positive 4 and positive 2 by inspection. So in the numerator, I have 2x squared. Negative 8x plus 3x is a negative 5x plus 6. So I claim that if you add f and g together, and that should have been a g right there, that you would get this new function. And they would expect me to at least simplify it to add these two fractions together. That's my answer in part A. All right, so here I want to subtract. So it's the same work, it's the same idea. We've got 3 over x minus 4. And we've got 2x over x minus 2. And we're going to subtract these. So to subtract two fractions, again, we need a common denominator. So this factor here is this denominator is missing a factor of x minus 2, and this one is missing a factor of x minus 4. So I multiply both of those fractions by the number 1 so it doesn't change their value, but it does change their appearance. And x minus 4 times x minus 2 is the common denominator, because this denominator and this denominator are the same except for the order of multiplication. And you can switch the order of multiplication. Multiplication is commutative. In the first term here, again, I have 3 times x minus 2, so I have 3x minus 6. This time I'm subtracting, and I'm going to subtract the whole thing. Let's take 2x times x, which is 2x squared, and 2x times the 4 minus, and now since I'm subtracting, I change the sign in terms of each binomial. I've got 3x minus 6 minus 2x squared plus 8x, all divided by this x minus 4 and x minus 2. And I'm just going to leave the denominator like it is. I'm not going to bother multiplying that out. I've got negative 2x squared. 8x and 3x is 11x minus 6. I just thought about it. Sometimes it's possible to factor this and then cancel common factors, but I'm not going to expect you to do that yet and stuff until we get to a later skill packet 4. So let's just leave our answer like this. I don't believe that that's going to factor anyway, but to at least not to have one of those as common factors to reduce. All right, so what do we got? Let's do division now. So this will be a complex number, which isn't too terrible. The numerator itself is a fraction, 3 over x minus 4. And that's being divided by g of x, which is 2x divided by x minus 2. So this fraction bar right there is division, and you can change that division to multiplication, and I can multiply these two fractions together if I take the reciprocal of the divisor. If I flip this, x minus 2 is now in the numerator and 2x is in the denominator. And when you multiply fractions together, it's so much easier than adding or subtracting because you don't need a common denominator. You just multiply straight across. So in the numerator, I'm going to have 3 times x minus 2. And in the denominator, I'm going to have 2x times x minus 4. I don't see any common factors that reduce. So well, you know what? Let's just leave our answer like that because many times, at least the denominator, we want it in factored form anyway. And the numerator, it's easy to sit there and say 3x minus 6. I'm going to leave my final answer like that because, like I say, later on, we'll see the advantage of having that denominator factored. We can see one advantage now in finding the domain that would help us. So now here's our function composition. Remember that we start with the second function and we input x, and g says that that should be a g right there. That says that the output is 2x over x minus 2. So that becomes the input for f. Well, so what does f always do to the input? F always takes the input no matter what it is, whether it's something complicated like we have or just something simple like a number, and it creates a fraction. The numerator is always 3, and the denominator is always the input, no matter how simple or complicated it is, minus 4. So here our input is this fraction. So we have this ugly fraction, 2x over x minus 2 is the input, and I'm going to subtract 4. Well, they expect me to simplify a complex fraction. You don't want to leave your answer as a fraction within a fraction. And once again, a common technique in algebra is to multiply by the number 1. So I'm going to multiply this by the number 1. But I'm going to be clever in how I write 1. I'm going to look to the denominator here and use this denominator and write it as x minus 2 divided by x minus 2. So it's actually not that bad if you know how to multiply the denominator. In the numerator, it's just 3 times x minus 2. And in the denominator, this x minus 2 gets multiplied by both terms. It distributes over the subtraction. When you multiply it times the first terms, the two x minus 2's cancel each other, and you're just left with 2x. And then in the second term, you don't lose your subtraction, and you have 4 times x minus 2. So they would expect us to clean this up a little bit in the denominator. I'm going to leave my numerator alone. My denominator, I have 2x, take away 4x plus 8 for a final answer, 3 times x minus 2. And here in the denominator, negative 2x plus 8. And I'm not going to even distribute that. And I can see that even if I factor out that negative 2, that I don't have a common factor, that I would have a x minus 4. There's no way for me to reduce this. All right. So hope that helps, and I'll talk to you later.